So, as always, you can always change into your directory, and you will do git pull main, and that should download all of this stuff. Okay, so git pull upstream main should get you all of the latest materials for the class. So that includes today's lecture, and we'll go ahead and get started. Today we'll talk about tuples. Okay, tuples are another kind of iterable structure. They are a lot like lists, and a lot of times we describe tuples as immutable lists. That might be oversimplifying things, but because tuples can be very, very useful. You might think a tuple is actually less useful than a list because lists you can expand and append values and change the values inside a list and things like that. Whereas a tuple is kind of everything is locked in, but they serve different purposes. You use a list when you want that ability to change things. You use a tuple when it's important that things kind of remain static, right? So if you're like recording records or you're recording information and stuff, then a tuple can be the appropriate data structure to use there, right? So here we go. So tuples are like lists in that they contain objects of different types, and the order and the values are preserved. Okay, in that they are immutable. You can't append to a tuple. You can't modify the values in a tuple, and you can tell it's a tuple because you will use parentheses rather than the square brackets. Right? To create a tuple, just use some commas. Okay, if you use some commas, then the object, then Python is automatically going to make a tuple. So even though I didn't put any parentheses here, this automatically creates a tuple, and you can see, well, what is the contents of this? And here we have a tuple. And of course, if you want to use parentheses, you can use parentheses, and that will be correct as well. So this is what we've got. Okay, and so these two things are exactly the same. All right, you can even have a tuple that only has one value in it. You just have to add a kind of a trailing comma. So if you do this, you can do the letter A with a comma, and that will create a tuple. And just to kind of check, you can ask, what is the type of this thing? And that says tuple. The length of the tuple is it's a length 1 tuple. Okay, if you just use parentheses, as if you're kind of creating a tuple and you put the letter A in there, but you don't put a comma, then this is just a string. Okay, putting the trailing comma will create a tuple. Okay, so if you want to create a tuple, of course you can also use the function tuple to kind of say, this thing that I'm making is going to be a tuple, and that's another way to do it as well. All right, so just kind of like you have list functions and dictionary function, you can also just kind of create a tuple using tuple, and this will work. This creates an empty tuple if you don't have anything in there. If you put in any contents, of course that will be the contents of the tuple. And you can also take any kind of other iterable and convert it into a tuple using the tuple function. Okay, so if I take the string hello, okay, so again, in Python, strings are iterables. They treat kind of every character as an element of an iterable. And so if you say tuple on hello here, this creates the tuple where every character becomes an element in the tuple. Right here, if I throw range 5 object inside a tuple, and it creates a tuple containing the values 0 through 4. Or here's a list, and I throw that in a tuple, so you have any kind of list that you want, and that will also become a tuple. as well. And at this point, I hope you're familiar and comfortable with kind of the indexing rules that we have in Python. And so, so if you create a tuple with this, you can reference any kind of these objects. The item, the value at index 1 is apple. You can slice and you can say, go from 2 to 5, and that's going to get you 2 cat and dog in here. All right, so we've got that. Let me go ahead and give you your first view quiz answer. First view quiz answer today is the letter E. E as in elephant. First view quiz answer is E. Okay, and I realize there was a mistake in one of the earlier view quizzes, and so I'll have to go back and correct that. So just give me a little bit of time to correct the your responses to the mistaken view quiz. But today, first view quiz answer is E. Okay, so just to kind of emphasize that tuples are immutable and they cannot be modified, right? Whereas lists are mutable and can be modified. Here I've created basically two things that are almost the same. T is the tuple, L is the list, all right? And so, as far as the creation, they look almost the same, except the tuple, we use the curved parentheses, and here we have the square brackets to indicate that it's a list, all right? So here with a list, you can say element 0, I want to change to 100. We want to take 100 and assign it to index 0, and indeed it updates the list. Whereas with a tuple, if you try to do something like this, you get an error. It comes back and it says, this is the wrong type of object that you're using here. A tuple object doesn't support item assignment. So it comes back and it gives you an error and it says you're trying to change the tuple, and that's not allowed. Okay. Over here, you have methods for lists that kind of modify the list. So if you want to append the value X to the list, you can do that. If you try to append a value to a tuple, it's going to come back and say, there's no attribute or a method for a tuple. You can't do this. Okay. So these are built into the structure of the tuple, right? And so it's not just like, well, why don't you just use a list for everything? Because a list and a tuple, for a lot of purposes, are very similar. But in some cases, you actually don't want the ability to change something. You want it kind of stuck in place, okay? And so, but you are, let's say you did want something else, okay? You can replace one tuple with another. There's nothing wrong with that. And so if you do need to do that, you can just create another tuple. So for example, here's the tuple. The original one, I think, has the value 0. Okay. If you want to replace kind of the first element with the letter A, you can create an entirely new tuple. Okay. So here I'm creating an entirely new tuple where I'm basically using the addition operator. So remember, the addition operator will take two lists and kind of join them together. Same thing with a tuple. You can use the addition operator and it'll take two tuples and kind of join them together to create a longer tuple. And so here I create a tuple of length 1, and then I subset the second tuple to go from index 1 further. Okay, and then we join them together into this tuple here. Okay. So this is an entirely new tuple. As far as the object in memory, it's an entirely new object. Okay, just like if you created a new string, it's a new string in memory. Strings themselves are immutable. As far as comparing tuples, okay, comparisons with tuples work like other sequences, and so it's kind of so here's a tuple of numbers. And the way it works is it compares the first element with the first element, then it goes to the next element, and it compares those two. And so here 1 is less than 3, and so it comes back true. Okay, once it's not, this might feel a little strange because in R we you kind of have like element-wise comparison for a vector. Okay, but this is not a vector. It's not treated as a vector of 3 values. It's treated as one object, a tuple, and you can almost think of this as like the word A, B, C, right? If you have A, B, C, and this is maybe like A, D, E, or something like that. Okay, and we're basically asking it: does A, B, C come before the letter A, D, E? Sorry, give me a second here. Okay, and so we're comparing, and so we just compare the first element with the first element, and then the second element with the second element, and as we have basically a difference here, and the 1 is less than 3. Okay, here's another example here. So it doesn't matter what in this case, because the second element is less than the second element over here, it doesn't matter what this is over here. That doesn't matter. Okay, here the second element is 500. Second element over here is 3. And so this thing is greater than this thing, okay? And it goes element-wise. So comparing the first and first. In this case, the first is tied in all of these scenarios. Does that make sense as far as comparing one tuple with another? We're kind of going element-wise. We're not doing an element-wise comparison where we're going to get 3 true or false values. We're doing one object compared to another object, but we compare it, almost just comparing each element against the next element. Do the tuples have to be of the same length? I don't think so. Let me just double check here before I make a mistake here. So let's say we have tuple 0, 1, 2 versus 0, 1. And that's fine. And if I do 0, 2, that becomes true. If I do 1, comma, yeah. So they don't need to be the same length in here. We would just kind of compare the first element with the first element. This is less. If I do a 0 here, this is not. This is not less. If I do 2.1, this becomes true. Okay. Can you compare tuples with less than or equal to? Yes. That's fine. That's fine. How does comparing tuples of different lengths work? You can kind of think of it as like, how would you alphabetize, like which comes first? ABC versus ABCD, right? And basically, I could pretend I have tuple ABC versus, you can think of this as something like this, right? So which comes before the other? The ABC comes before the ABD, right? Whereas if we have another ABBB comes before ABC, right? As far as words of different length, right? If we had to alphabetize these things, right? So we look at this and we go, oh, the B is before the C. I hope that makes sense, what's happening here. Okay, so tuple assignment. So we've kind of seen functions return multiple values in the form of a tuple. And with Python, there's a common idiom that's useful as far as kind of swapping the values using a tuple. So you can just say, here A is 5 and B is 1. And if you didn't have tuples, if you wanted to switch so that B becomes 5 and A becomes 1, you would have to create a temporary variable. You would take the value 5 and store it into temporary. You would take B, store it into A, and then you would take the temporary value and store it into B, okay? Because if you just did B equals A and A equals B, this value is going to end up, you're going to end up getting 2 of the same value, which isn't what you want, okay? But with a tuple, you can just do this. You can do A and B become B and A, and that's going to swap the values. So you don't need to have this temporary value, right? So in R, you have to do this if you wanted to swap the values of 2 variables. But in Python, you can do this, and this is a very handy and useful idiom to have. Okay. So, you could take some kind of function. So a lot of times functions will return multiple values. And so, so you can do string.split. Okay, string.split is going to kind of create a list. So let me just show you before I do this. If I don't do the assignment, okay, string.split returns a list of string elements, right? And so here we're saying split this email address on the @ sign, okay, and it returns back a list of elements, okay? But what I can do is I can say, you know what, take that and assign it to uname, username, and domain, and then now those 2 things get directly assigned to the characters. So you can kind of take any kind of function that's going to return multiple things or a list of multiple values, and you can, kind of piecewise assign them as such, right? As long as when you do some kind of unpacking, you need to have the number of elements here need to match the whatever the length of this function here. All right, and so, when we created functions, you could have it return multiple values as a tuple. And so this is this function, right? You can take a x and you can do basically integer division and with the remainder, and you can say, x / y will give you the integer portion, x mod y will give you the remainder, and it will return a tuple. So you can say, all right, what is 23 divided by 5? Well, 23 divided by 5 is going to be 4 with a remainder of 3, right? Because 5 goes into 24 times, and then you'll have 3 left over. And so when we run this, A is going to be 4, B is going to be 3, and we can kind of produce that output, A and B. All right, or we could look at A individually will take on the value 4, B individually will take on the value 3, okay? This function already exists. It's not called myDivide, it's called divmod, modular division. This is a built-in function of Python that does exactly what I've written out here, okay? So you do divmod 23.5 and you're gonna get 4, 3. And you can do whatever you want with this, which is, I think your first exercise in your homework, basically you're going to do some divmod stuff to get your time, right? Everything's reported in seconds, and you'll divide by 60 to get how many minutes, and divide by 60 to get how many hours, et cetera, et cetera. Okay. As far as methods that exist with a tuple, you have the index method and you have the count method. And these work the same way as the index and count method do for lists, okay? And so here's the tuple that I'm creating, and you can say, all right, what is the index of the element dog, okay? And it goes through and it says, oh, okay, dog is at index position 4. You can say count, how many times does the element 5 appear in the tuple? The element 5 appears 1 time. Okay. And, you know, I think I showed you some of these examples with lists, and, you know, if you give it something that doesn't quite exist, you know, you're going to get an error and stuff like that. All right, there are a bunch of functions that support tuples and other iterables. So these apply not just to tuples, but also lists and strings and dictionaries. And you can do stuff like this, right? So len will return the length of the tuple. Okay, so you could say, you know, what's the length of this tuple of numbers, and it's going to come back and says, you know, there's 7 elements there, right? Some words is a list, and you can do operations there. You can say, you know, if you have numeric values inside the tuple, you can apply the sum function, and it will add them up and do exactly as you expect. If you try to, you know, run sum on a list or tuple of characters or strings, it's going to come back and give you an error, of course, because it says that's you're not allowed to do something like that. And again, with you can run sorted. Okay, now keep in mind, sorted is a function that accepts a tuple. Okay, but it will not modify it, right? So it gives you back a sorted version of the tuple. So it's going to take the elements inside inside here, and it's going to sort them. Okay, and it returns the object that it returns is going to be a list of the elements of the tuple, but in sorted order. Okay, but again, the original values in the tuple remain unchanged. Sorry. Okay. And again, you can apply it to a string, I mean, list of strings and things like that. You can also ask for the minimum or the max and things like that. Those functions also work for dictionaries. And so here I've got dictionary number, where the keys are numbers, the values are letters. And here I've got dictionary alpha, where the keys are, you know, alphabet characters, characters from the alphabet, right? The length is how many items are in the dictionary. When you call sorted on a dictionary, it's going to give you a list of the keys, but in sorted order. Or, you know, here's sorted on the dictionary where the keys are letters, and that it gives you the thing that's sorted. Okay, max, you know, exactly. It's the maximum key, right? So as far as the numbers go, the max key is going to be the number 3. If we did max on dictionary alpha, it would come back with the letter C. You can apply multiplication and addition symbols to these things. So sorry, there's a question that says, is there a setting for the notebook to autofill or show function methods as you type? I think it supports certain, I think it's got autocomplete for variables that have been created, but it might be a tiny bit slow. So I think if I type in UN and I hit tab, it loads up and it says you can do something, right? So I can do, you can hit tab. So there should be tab completion for your dictionary. It just, depending on your computer and browser, sometimes it takes a second to respond for tab completion. Okay, so basically, I think you guys are familiar with the multiplication and addition for strings, and basically it works very similar to lists and tuples. It's just it treats these things, right? So here's with the lists, and you can do the list times 2, and it works almost like if this were a string and you did times 2, just kind of duplicate it. With the list. It extends with duplicates. If you do plus, it concatenates the two things together. And this would work for tuples as well. Okay, so as far as tuples go, you do the multiplication, you do the plus, it does these things. These are entirely new objects that have no relation to these objects themselves. So this is, we're not modifying tuple 1, we're not modifying tuple 2, we're creating an entirely new tuple here. That, you know, if we wanted to, we can assign them back somewhere. Okay. You can't combine lists and tuples together directly. You have to convert something into something, right? So here I could take the tuple and I could convert it to a list, right? And then it will work. So as far as combining different types, that's not allowed. All right, let me go ahead and give you your second view quiz answer. Second view quiz answer today is the letter C. C as in cat. C as in cat is your second view quiz answer. Okay, let me just make sure. Yep. All right, so one thing that is quite handy in Python is it allows for variable length arguments inside functions, okay? And so you can take some parameter name in a function and throw in a star, and what that will do is it's going to gather arguments together into a tuple, okay? When you do this, it's often used, we'll often call it Starargs, but you know, this thing args could be, you know, whatever you want it to be. Okay, so usually it's just Starargs is most common. And so here's a function where I have a multi-length argument here. And what this star will do is it's going to just combine everything into a tuple and throw it into that tuple into print. Okay, so here, if I throw this in, okay, with the star, it's going to gather these 4 elements into a single tuple, and then it basically prints out the tuple, okay? Whereas if I didn't have the star, what would happen is we would get an error, because here it's expecting just one argument. If maybe I should just show you the demo, or just kind of do it. So if I did this, if I print all here, and I say, copy this here, you know, here we're going to get an error because it says we're expecting just one argument, but you gave me 4. Okay. Whereas over here, if I define the function using Starargs, and I give it 4 arguments in here, it's going to gather those 4 arguments together into a single tuple, right? And it's going to allow it to work, right? So this is just like a very, very, very rudimentary type of function, but you know, we can do you know, some more interesting things. Okay, so I mean, this isn't that interesting, okay, but here we can take print lines, and it's going to take, you know, however many elements I want to give it. It's going to gather that into a tuple, and then, you know, within the function we can iterate over the tuple. So we could say, you know, for each element in that tuple, just print out that element. Okay, and so we get hi on the first line and goodbye on the next line. You know, here's just a bunch of values, 1, 5, 7, 9, 10, and each of them get printed out on its own, on their own line. Okay, and so you can think of other things that could, where you're going to gather multiple things together. Okay, and on the flip side is you have basically scatter. So you have gather and you have scatter. Okay, and that also uses the star operator, right? So let's say you have some kind of sequence of values, and you want to pass it to a function where the function takes multiple arguments. Okay, so here, you know, we have the function myDivide, and it takes in 2 arguments, x and y, right? And then it, you know, does basically modular division here. And here I'm going to create a tuple 23 and 5, right? If I give this function myDivide the tuple directly, this doesn't work, okay? Because it's seeing, it's going to see X as this tuple 23, 5, and it says, we're missing something. We don't, we need something for Y, and you haven't given me anything for Y, because it's just seeing the object gets assigned to X, right? So what you can do though, instead, is you can put in a star in front of the tuple, right? So you pass it, the tuple will just, so you pass it the single tuple, but you put a star in front of it. And when you do that, it works, okay? It's going to take the elements inside the tuple and it's going to scatter them into X and Y, and it's going to function, okay? So the function works here with the scatter operator. Okay, and so both of these are using stars. So you can put the star in front of the tuple when you call it, if you're trying to take elements in a tuple and scatter them across multiple arguments in the function, or you can use star in the function definition, and it's going to accept multiple elements and gather them together into a single tuple. So, we saw the zip function, okay? The zip is a built-in function, and what it's going to do is it's going to take basically two iterables or two sequences and is going to interleave them together, right? And so it's kind of just like take one from this element, take one from the other, take the second from this element, and take the second from the other, and so on and so forth. So here I've got a string ABC, I've got a tuple 0, 1, 2, and I can zip them together, and what it's going to do is it's going to join the A with the 0, the B with the 1, and the C with the 2. Okay, it's going to zip those together into kind of a list of tuples, right? When you call zip, it creates just a zip object, and it tells you the address of the memory location where this is stored, okay? Is there a star kind of like a pointer in C++? I'm not quite sure what you mean by that, but so the star function in Python will create tuples or will gather elements into a tuple if you have a star in the function definition. If you use a star during when you call the function, it's going to take the tuple and it's going to scatter them into multiple arguments. All variable names inside Python are pointers, okay? All variable names inside Python are pointers, so that, it's not like the variable is defined to be a certain data type or a certain location in memory. It's just the variable name just gets pointed to whatever object we have here, okay? So, so here, when you call zip, it creates a zip object. And we don't really make use of it, so that's the end of that story, okay? But here, I can take that zip object, right? So we're gonna zip S and T together, and we're gonna run a for loop. We're gonna iterate over that zip object, and so the zip object, is an iterable, and so we can go through each pair, and basically, the zip object basically creates a sequence of tuples, okay? And so if I just say print out each item in the iterable, we get the first tuple, which is A and 0, the second tuple, which is B and 1, and the third tuple, which is C and 2, okay? So the zip object is, what we call a iterator, and it's going to kind of iterate and generate a sequence of iterables. Now, for the zip object, I believe, has a lazy evaluation, in that it's not like, if you have a zip object of like a length of billion, I believe Python is not going to actually compute the actual tuples of the zip object until it needs to, okay? And so it's kind of like saying, join all of these things together, and it's just going to kind of join them together as it gets to that point. And so it's not going to actually create the whole thing. Now, if you take the zip object and you put it inside a list, then it will join everything together and store it into a list. So if these things are very, very long, then this operation could take a while, right? So zipping them together will be very quick, but then if you take the zipped object and you throw it into a list, if the zip is very long, throwing it into a list could take some time because you're asking Python to actually go through and actually perform all of the zipping. Does that kind of make sense as far as the difference between saying, I want you to zip it, and when we get to it, give me the answers, and Python will do it just as it's needed, versus saying, okay, zip them now, and I want everything all at once. And if you say, I want it all at once by throwing it into a list, it'll do it. It could take a while if it's really long. Now, for something where it's like, you just have 100 elements, 1,000 elements, it's going to be still instantaneous. So not to worry, we're just talking about like on the orders of millions and billions. It can take a while. Okay, so anyway, this is what you have. If the sequences are not the same length, then the result, it's just going to get truncated to whichever one is shorter, right? So, so here I have ANNE and then ELK, and the A goes with the E, the N goes with the L, the N goes with the K, and then the last E it gets truncated, all right? Because there's only 3 elements over here and 4 elements over here. If you do have a list of tuples, okay, so this could be the result of a zip thing, or you just happen to have a list of tuples. You can iterate over them, and when you iterate over them, you can unpack them, right? So as you iterate over a tuple, or as you iterate over a zip object, you can also unpack the elements, okay? And so here we're going to have the letter and the number, and we can print out the number, we can print out the letter separately, and we will get these things. All right, so here's just a little snippet of code that's just going to go through kind of 2 iterables or tuples or whatever it wants, and it's going to just kind of compare them element wise and return, is there a match between, this thing and this thing at that exact position, to see if there's a match between them at a certain position. So here I've got ABC and I've got DEF, and there's no match. A doesn't match with D, B doesn't match with E, and C doesn't match with F. Here I have ABC and DEC, and A doesn't match with B, or D, B doesn't match with E, but C matches with C, so that returns true. Oh, you know what? Here's another one where I have A, B, C, D. Sorry, I must have updated it, but not updated the slides. A, B, C, D versus D, C, B, A, and there's no match here. So even though we have common elements, A doesn't match with D, B doesn't match with C, C doesn't match with B, and D doesn't match with A. Okay, so even though the elements are shared, they don't match, positionally, and so this is going to return false here. Let me regenerate these slides here. So there we go. So I'll update the thing on GitHub in a moment. Okay. So there's a function called enumerate, and this is very handy. It's a lot like creating a range object and zipping it with some other iterable. So if you call enumerate on any kind of iterable, whether it's a string, a tuple, or list, or dictionary, well, I don't know, I guess you can do it with a dictionary, but string, list, or tuple, what it's going to do is it's basically creating a range object of the same length, and it's going to zip it together, right? So here is the word morning, okay? And what we're going to do is we're going to enumerate, okay? And much like the zip object, it creates an enumerate object, and it has kind of this lazy evaluation, and it's not going to give you the tuple or the the object until you actually need it, right? So here we're going to say, all right, go through and iterate over everything that that has been enumerated. And basically it's going to, the first thing in the tuple is the index, and the second thing is going to be the value. And so M gets basically zipped with a 0. And you get 1 goes with O, 2 goes with R, 3 goes with N, so on and so forth. Okay. So here, if we call enumerate on a list with A, B, C, D, you're going to get 0. You're going to get a list of tuples. Okay. 0 goes with A, 1 goes with B, 2 goes with C, 3 goes with D. Okay. Oh, this. Okay, you can kind of see it here if I shrink the text here. And if I call, if I create a range 4 object on, so here I've got A, B, C, D. So if I create a range 4 object and I zip it together and then I call list on it, I'm going to get the same results. Okay, so it's much like creating a range object of the same length and then zipping it together. But you don't have to actually write out that kind of idiom. There's a function already that does exactly this, and it's called enumerate. Okay, and again, we've seen dictionary view objects. Dictionary items is a dynamically updated kind of object of tuples. Okay, it's kind of a sequence of tuples. And so here we have the dictionary. Key A goes with value 0, key B goes with value 1, key C goes with value 2. Okay, and if I list off the items, basically I have a sequence of tuples, right? It's dynamically updated so that if I ever add, append a value to the dictionary, update any of the values in the dictionary item sequence gets updated as well. Okay, but you can iterate over it. All right, so much like you would unpack a tuple, you can do this and you can say, I want to print out the key and the value, or whatever it is that you want to do with the key and value in the dictionary. You can iterate over it. And so there's a lot of kind of things that you can do that are handy with the dictionary and in combination with other stuff, right? So you can take some kind of sequence. Okay, so here I just have a string EFG, but you can imagine anything else. You can enumerate it, and then you can throw that inside a dictionary. And so now you have a dictionary where each of these things get has an associated key. Okay, if you want to kind of swap the elements in the dictionary, again, we can kind of create an empty dictionary. We can iterate over all of the items in the dictionary, and then just put in, for the swapped value, we're going to use the value as the key now, and we're going to enter the item as the key. Okay, now again, if multiple items in the dictionary share the same value, they're going to get overridden here. Okay, so that's going to happen. And so I think in Wednesday's lecture, I kind of showed how to invert a dictionary, but allow for kind of multiple things to be associated with the same key there. Okay, so here would be the swap thing. If you got enumerate here, you can also just say, well, the opposite enumeration would be to zip the EFG with a range 3 object, but then just put them in the opposite order. So that's also possible. All right. I showed you this already, as in creating a dictionary out of a list of tuples, creating dictionaries out of zip objects, and it's much the same. All right. And so, one useful thing is you could actually use the tuple as a dictionary key, right? So because, so as far as dictionary keys go, the keys have to be immutable objects, right? So when you create a dictionary, you can use strings and numbers or tuples as dictionary keys. You can't use lists or other dictionaries as the keys. The values can be anything, but the keys have to be immutable. Right? And so here's an example where you might want a tuple as the key, right? So for example, let's say you've got some kind of function. Okay, you've got some kind of function where, I mean, this is a silly example, but perhaps computing the answer to the function is very computationally expensive, right? So I think in your homework assignment this week, there's this recursive function, the Ackermann function, and for values where once you go over 3, once you start getting over 4, the values get really big, really, really, really huge. Okay, and you don't actually want to compute it, right? So if I do the Ackermann function, so here's so it kind of just shows some of these things. So like if m is 4 and n is 1, it becomes the value 65,533. And at m equal 4 and n equal to 2, this is some ridiculously huge number, 2 raised to the 65,536. And so this is something you don't actually want to subject your computer to compute this, okay? So what you can do instead is you can create a tuple of known solutions. So you can, or I'm sorry, a dictionary of known solutions where you're going to kind of put in the coordinates as kind of your lookup value. So here, I'm going to start off with the known solution where if I plug in x equal to 0 and y equal to 0, the known solution to be 0, okay? And then what we can do is we can create a function so that if we get in some pair of coordinates, what it will do is it will look it up in the dictionary if that value already exists. So if the value already exists in the dictionary, it's going to look it up and return the answer, okay? And so we're going to say if t is found in known, right? So if t is one of the keys that it already exists inside the dictionary values, we're going to print out the value already exists in the dictionary, and we're going to just return the value that it finds in the dictionary, okay? And if it's not, then we're going to say, okay, we have to calculate the value, and then we go through the process of calculating the value. Then we'll store that result into the dictionary, and then we'll also return that result. Okay, so just to show how this goes, if I call the function on 0, 0, it's going to look up 0, 0 in the dictionary, and it says, that already exists in the dictionary, okay? Here, if we say, all right, look up, or what is the value of the function applied to 1, 2, it's going to see if 1, 2 exists in the dictionary, and it doesn't, so it's going to say it has to be calculated, and it calculates the value and comes back with 5. And then if we, but if I call it again later, and if I say, all right, well, what is 1, 2 later, this value has this thing, when it calculates it, it stores the value 5 into the dictionary. And so now when I call this says, oh, you know what, this exists in the dictionary, and it gives back 5. Right? And if we say, okay, well, what values do you have in your dictionary? Now we have 2 known values. We got 0, 0, and we have 1, 2 as keys. And so these elements are known. And then if we call for anything else, it's going to have to compute it, but it will add it to the dictionary, which is quite handy. And so you can set up something like this, where you can kind of almost have like a lookup table as far as key values go for the dictionary. Okay, we'll end here for today. And the last quiz answer today is the letter B. B as in bear. B as in bear is the last quiz answer. And we'll end there for today. And we will have a good weekend, and we'll see you guys on Monday.